In this small recording, I'm going to play a little bit with a simulation that's called the Slit Simulation out of WebTop, a webtop.org website. Actually, it's a project that I'm involved with. Again, you can have access to these simulations by going to http www.webtop.org, and you can download the whole set of simulations and then run it on your own computer. That's what I'm doing here. I'm running it off my own computer. Okay, so this is the way it looks when we run the simulation. Okay, now what we have here, we have the two slits, 1 and 2. We have a source of light. We don't see the light, but we can change the wavelength of the light here. We have a wheel that can change that. Okay, now we can change it manually by typing the numbers here. Like right now it's 570. 500 is going to give us green light. 300 is going to give us actually 400. I went too far. 400 is going to give us blue light. Now 700 is going to give us red light. That's the limits for the simulation. It gives us light from 400 nanometers to 700 nanometers for red. Now notice we can move the screen position, but notice the value here. What we call the z distance is the screen position. We have it at 1,000. It's arbitrary units here, but look at it as 1,000 compared to the slit width, which is 0.04, and the slit separation, which is 0.449 in this case. Now, I'm pointing those out to you. They are arbitrary units. They can be anything, just so you'll understand that the graphics here are not to scale. Like the separation between the slits is so tiny compared to the separation between the slits and the screen. And the width of the slit is so tiny compared to the separation from the slits to the screen. Okay, what I'm going to do here, I'm going to change the slit width. I can change it here by this widget. Okay, this is when it gets big, this is when it gets narrow. Okay. Okay, now what I would like you to pay attention to as I change the slit width, notice what happens to the positions of the maxima. See, they don't change. Some of them get dark, like here, we don't see them anymore, but they don't move sideways. I'm going to keep it small here. Okay. Now, what I'm going to do instead, change the slit separation. I can change the slit separation by, slit separation is D. If you remember the equation that we had for fringe separation, separation delta Y, it was lambda L over D. So there was nothing that was referring to the slit width. And that's why the slit width didn't have any effect, as we have seen it here. Now, but the slit separation D is going to have an effect. The closer we have them, the further away the fringes are. The further away and the wider they are. See that? So the closer we are, the further away they are. The further away they are, the more closer together the fringes are. Okay, the last thing I'm going to change, not the last thing, one more thing, I'm going to change the screen position. Okay, here. See, as the screen moves away, the separation increases. As the screen gets closer, the separation decreases. Very much like we expect it to. Now we would like to pay attention to the wavelength. Look here, for example, when we have 700 nanometers for red light, we have 3 fringes in the screen. What about if we have 650? Okay, you see they are getting narrower. 600, even narrower. 550, even narrower. We are starting to get even more fringes in that screen. Okay, now we have, instead of 3, I can say very easily 5, probably even more. 450 and 400. So the smaller the wavelength, the smaller the separation between the fringes, or the narrower the fringes are.